Thanks for the time today. I'll probably be a little bit brief. I'm going to put my background just in context of today's discussion, which is a little bit different from the rest of the talks today. I've got a background in geology, aerospace engineering, engineering, mining, and it's actually medicine. And I'm running a company called Lunar Helium-3 with the singular and sole focus of going to the moon. We are working on the technology to extract helium-3 to bring back to Earth for future fusion, which will make fusion totally green, along with cooling quantum computers. We actually believe, and it'll be a bold statement, that this is the primary business case to go to the surface of the moon with an ongoing presence. But what does that have to do with today's discussion? If we don't solve a dust issue, and not with necessarily equipment external to a habitat, but with the dust inside a habitat, we're not going to be spending a lot of time on the surface of the moon. If you look back at some lessons learned from the Apollo astronauts, they all developed what they called back then lunar hay fever. And what they were actually doing was breathing in lunar dust within the habitat. And the Apollo systems, the air handling systems, were fairly rudimentary compared to what Artemis will have. But at the end of the day, if you're doing EVAs, bringing equipment in and out of a habitat, it will be virtually impossible to keep all the dust out of the habitat. So a working assumption is there will be dust inside a habitat. So that's our focus of today's discussion, that there will be dust no matter what the mitigation strategies are. So if there's dust in a habitat, who cares? If it was Earth-based dust and it's sitting on the floor, you wouldn't really care. But lunar dust is not Earth-based dust, and lunar dust actually can kill you. So assume there'll be lunar dust in a habitat, assuming the air handling systems cannot get down to the sub-micron level. So what does this lunar dust do? If you breathe in lunar dust at about 10 microns, it will get to the bottom of your lungs. But if you breathe in lunar dust that's less than 0.1 micron, it actually crosses the blood-brain barrier and it can go into your actual brain. So this dust is very caustic. It can go into your lungs. It can go into your brain. And again, what does that mean from a medical point of view? There's animal studies that show this acts very similar to silicosis. You potentially can get COPD with this, have major allergic reactions that would require you to be on oxygen. As you progress and breathe it in longer, it takes months for it to come out. It could lead into tumors and even neurological damage. So this stuff is bad, and it's going to be inside a habitat. And the air handling systems that are being designed won't get rid of all of it. So you look beyond that and say, okay, if you make these assumptions, can you wear Earth-based mitigation systems like a N95 mask or a cloth mask or something called a PAPR? And the answer to that is no, for a couple of reasons. One, no one's going to wear an N95 mask for a month inside a lunar habitat. You can't really wear it. It's very claustrophobic. It's difficult. You can't really work with it. So there's no Earth-based systems designed to actually mitigate this problem. So we actually designed a system under the assumption the dust will be in the habitat. And the system we came up with is a synergistic system. It has a mechanical component and it has a non-mechanical component. So on the mechanical component side, imagine a baseball hat, sort of helmet like this that could be soft. The power source is in the back, on your back or on your hip. And the first part, the mechanical part, draws the air within the habitat through a HEPA filter, which will filter out about 99.9% of dust down to 0.3 microns. Small particles lower than 0.3 microns will pass into the system. At that point, the air is ionized. So anything that's negative will stay negative. Anything that's positive will be converted negative. Anything that's neutral will be converted negative. So you're going to filter air, ionize the remaining air, and it's going to come out the brim of the hat in front of your face. That will be filtered, negatively charged, ionized air. The second way this system works is there's electrodes on the side of the face built into the brim of the hat and the side of the hat that will have negative charge coming out there to repel negative dust. So the system is designed to use an airflow with filtered air that's charged negatively, along with electrodes to create an electronic field in front of the face. And the whole goal is to mitigate the dust in front of the face before you breathe in the dust. So we're at tier level 2 at this device. We'll be looking to expand this out further. There may be earth-based applications with a modification of the design for underground mines and for construction. But the main focus, again, is on the moon. And again, I go back to Gene Cernan, who was the last Apollo astronaut. To paraphrase him, he said, we can overcome a lot of issues with working on the moon, but if we don't overcome the dust issue, you're just not going to survive on there. So again, our company is looking at mining the moon and having a presence on there long term. And unless we can solve this issue within a habitat, us and other people will not be able to survive within a habitat on the lunar surface. And with that, I yield my time back. Thank you for your time.